Good morning, ladies and gentlemen. Welcome to this video about theoretical probability. Now, what we're going to look at here is the chance that something will happen in theory. It doesn't guarantee it will happen or guarantee it won't happen. It's just the theoretical chance. So, for example, the probability of rolling 3 sixes in a row on the dice is small, but that doesn't mean it's not possible. Same as the chance of rolling a number bigger than 2 on a dice is high, but it doesn't mean it's guaranteed to happen. So it's just the probability, in theory, that an event will occur. And the way we calculate theoretical probability is the number of wanted outcomes divided by the total number of equally likely outcomes. So, for example, the probability of rolling a 3 on a dice, well, there's one 3 on a dice, so there is one wanted outcome, divided by the total number of equally possible outcomes. And the total number of faces on a dice is 6. So therefore the probability of rolling a 3 is 1 in 6. Probability of tossing a head on a coin, well, there's one head out of 2 sides. Therefore it's a 1/2 chance. You could also express that as 0.5. Both ways work. Okay, what if we tossed a dice and a coin together? What is the probability that the coin lands on a head and the dice lands on a 3? Now that's a more complex question. So what we do in this case is we introduce the concept of a sample space. A sample space, very simply, is a list of all possible outcomes. And often we use a table to organize ourselves into a logical sample space. So when we have a coin and a die, and we toss them together, this spot here represents a 1 and a head. This spot here represents a 1 and a tail. And what we do is we fill this table in 3, 4, 5, 6. Can't even count. 2, 3, 4, 5, 6. And you can see that when we toss a coin and roll a dice, taken together, there are 12 possibilities. Therefore, the probability of a head and a 3 there, that is one outcome we want out of 12 possible outcomes. What about a tail and an even number? If we're looking for a tail and an even number, we can go through our sample space and identify how many meet that criteria. That one does, and that one does. Therefore, the probability of rolling a tail and an even number is 3 possibilities out of a total of 12. If we want to simplify that, is a quarter. So a quarter of the time we do throw them both up in the air, they'll come down as a tail and an even. Now, one more example. A coin and a pentagonal spinner with sectors 1, 2, 3, 4, 5 are tossed and spun, respectively. Draw a grid to illustrate the sample space of possible outcomes. Alright, in that case here, a coin. You can do it any way around you want, but a coin on top would yield 2. Either it's going to be heads or it's going to be tails. And then down this side here, we can imagine the spinner would release one of 5 numbers. 1, 2, 3, 4, 5. And therefore our outcomes are, 1 and a head, 1 and a tail. And so on. Head, 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 tail, 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 2, 3, 4, 5, 2, 3, 4, 5. How many outcomes are possible? Well, if we count them up there, the answer is 10. Use your grid to determine the chance of getting a head and a 4. Well, there's only one possibility there, and that's 1 out of 10. What about an even number? Well, an even number, there is going to be 1, 2, 3, 4. There is 4 out of 10 possibilities. We could write that as 2 over 5. Of getting a tail and an odd number. So a tail and an odd number would be there, there, there. There are 3 possibilities. 3 possibilities out of a total of 10. A tail or a 3. Careful of the word or. A tail or a 3 means only one of those has to happen. So a tail, sorry, my pen is just not behaving itself. A tail is any of these. 5 of them, or 3 there, meaning there are 6 out of 10. So careful when it says or means one or the other or both. So you only need one of them in order for it to count as a success. Whereas when it says and, you need both of them. Alright, from here, there are questions for you to answer. Enjoy, let me know if you get stuck.